One thing to add is we have the Outstanding Volunteer Award, which is intended to honour peer-nominated past members who have shown extraordinary dedication and effort in the service to the data professional community. So please do send your nominations to volunteerrecognition@sequelpass.org and a few notes along why they should be recognised. So we're also looking for nominations for the Passion Award, which is the highest of PASS accolades presented yearly to a single volunteer who has made a significant contribution to PASS. I won this award in 2012 and it was really amazing. I never expected to win it. So if you want to give someone the same experience that I got, then definitely please nominate them. So today's session is all about the usage of R in SQL Server for better data understanding. Now I'm really excited about this. I'm interested in all things R at the moment. R for statistical computing is a powerful language for data analysis with all the great features for data import from the SQL environment. It will help data scientists and data analysts prepare, explore and validate data much more easily, as well as using a wide range of statistics. So today our speaker is Tomaž Kaštrun, who's in a hotel in Salzburg, which sounds really exotic. I've only been to Austria a couple of times. I've been to Vienna, but I would love to be there. So one day I will hope to go to Salzburg as well. So Tomaž is a BI developer who focuses mainly in data mining, data quality and programming in SQL and .NET. So I'm really excited to hear his session, and if it's all right with you, Tomaž, I will hand the screen over to you. And I will hand over to you. Thank you very much, Tomaž.
Thank you, Jen. Thank you everybody who's listening and attending, and thanks again for a beautiful introduction. Yes, indeed, I am in hotel and I'm having a bit of trouble with the internet connection. Anyways, as Jen has already mentioned, today's session will be mainly about the idea how to use the R in SQL Server data, and mainly on transactional data and dimensional data. And the idea came effectively when there was no how to connect R with SQL Server, and that's why I've prepared this framework for using R with SQL Server. As Jennifer already said shortly about me, I have more than 10 years experiences with SQL Server and other databases. I've been programming, have been doing data analysis and data mining. Currently I'm working at a SSRS, my Twitter account and my Tumblr blog, something on blog where I write a couple of jokes on a daily basis. Anyway, so let's start. So analyzing data, yes, it's a painful task. Everybody who's working on the data has to do it, especially if you are preparing some sort of data analysis, stuff like that. You need to first clean the data, you have to get the data, you have to understand the data, etc., etc. And how does it make you feel when you're analyzing the data? Well, yeah, everybody knows that. Especially if you're doing it on a daily basis, yes, it might be painful, especially if the data are not cleaned prior to the data analysis, etc., etc. And mainly the analysis comes from the transactional data, dimensional data, and OLAP data. OLAP data are far the best because they're already somehow pre-prepared, flattened, stored in a way that data analysis, data scientists can use, whereas transactional data are usually very raw, with everything that comes inside, with maybe timestamps, with a lot of IDs, with some GUIs, whatever there is in your system. And dimensional data, it's more or less just a compact set of data where you just have to be very careful what's inside, if there are any values, what kind of values there are, and so on and so forth. So all these types of data can be analyzed and must be, when you are preparing some sort of analysis, must be taken into consideration. So what does SQL Server in this first instance give us? It gives us a couple of built-in functions, mainly for exploring and understanding the data. So mathematical functions, we all know, aggregating functions, ranking functions, and string functions. Based on these functions, one can already do quite a lot. You can imagine using mean function, max function, sum function, average count, etc., etc. You can get quite some of the understanding of the data. But mostly, all of these functions will just give you a set of univariate analysis, or just analysis on one column. So what if I'm interested in, what if there is, my question for instance, what if there are any influences between gender and my profit? For instance, that women generate more profit in my company than men, or vice versa. So in this case, I can do something with some aggregate functions, with some mathematical functions, but I'm not really sure whether there are any statistical significances on this data and so on. So in this case, I would definitely be interested in more bivariate and multivariate analysis of the data, where in this general statistical functions, it might not give you the results that you want. So you always ask yourself the question, okay, are my data actually statistically presented? Are this really something that I'm interested in? So yes, I can generate all these mathematical functions on transactional data, but what if I need more? In this case, yes, SQL Server comes with a variety of pre-built, pre-installed and available tools such as data mining, which is a totally separate field in the BI. It can give you, for instance, if you are building all-up cubes, you can generate quite a lot of multi-bivariate and multivariate tables, but effectively it will not give you, it will not generate you the tasks that you want to do. On the other hand, you have data quality, you have master data management, which will definitely also give you some predefined functions such as data duplication, searching for the missing values, imputation of the missing values, and so on and so forth. But on the other hand, if you are more hacky, and if you are interested in more writing T-SQL, for instance, such as Itzik and Khan did it, and a couple of other guys, they've actually created mean or median or models. Those who are with statistical backgrounds, those are the measures for the statistical measures of the mean. They definitely they wrote transact SQL code where you can generate, for instance, median. But t-test, t-square, variance, and so on and so forth, it's a bit harder, it's a bit more, you have to know a bit more statistical knowledge, and of course it will take you quite a lot of time to generate T-SQL, especially when you want to go deep into bivariate or multivariate statistics. In this case, SQL Server will definitely not provide you with this set. It will give you, for instance, as I've already mentioned, data mining. It will give you, if you're interested in analysis services, it will give you the data profiling, which is also a beautiful tool. And of course, yeah, you can always export all the data to Excel file and generate effectively a lot of things also there. I will not talk about Excel today because I'm not really a fan of Excel, although it is a great tool and everybody likes it. Yeah, unfortunately, fortunately. But in this case, I will just try to focus on R. So what is R? As Jennifer in introduction already said, it's a language, it's a software environment for statistical computing and graphics, but it offers you a lot in terms of statistical analysis, in terms of analysis of the web, in terms of if you want to do any kind of statistical analysis whatsoever, it just is there. My favorite point is it's free of charge. It's available It's been a long-going process, developing process. It's an open source, which already means that you already have all the latest upgrades, all the latest libraries are upgraded, all etc., etc. There is a strong community and also a good documentation, which is also a good point. In documentation, you have a lot of books with R. You can do statistics with R. You can do everything with R. And that's about it. And where does the idea come from? Setting R and using R in SQL Server. As I said previously, SQL Server is a database engine. It's not a statistical tool. Although it provides, as I already said, data profiler, you have a lot of fuzzy stuff in integration services. You have data cleaning. You have a lot of things pre-prepared. But just simply, if I want to, my question was, what if I want to run a simple frequency on my column? Let's say I have a transactional data, I have gender, and I want to see the distribution of this gender. Okay, and then I said, okay, do I really need to write each and every time 10 lines of transactional SQL code just to see my distribution, just to see the frequencies? My background, I've been using, for instance, tools like SPSS, which now is which was acquired by IBM. It was just drag and drop, or just 2 clicks away, and you get the distribution. You get the idea. What are you dealing with? What kind of data are you having? With SQL Server, yeah, it's a bit hard. We have to deep dive, do some codes and stuff like that. So, yes, and at the end, the idea came basically from that I will definitely create some sort of framework where R will be an engine on the background doing all the statistical analysis, and SQL Server will just hold the data. So this was one idea. The second idea was definitely detecting outliers. Outliers are also pain in the for everybody who is working with the data, because if you have undetected outlier, it will definitely generate you very, very wrong results, especially if you're, for instance, with financial reports. Just missing out one outlier will just give you a totally wrong picture of your, let's say, your financial situation, your financial sales data, etc., etc. Also, missing values in transactional, as well as the missing values in dimensional data, will also give you a vague picture. I'm not going to say wrong picture, but vague picture, because those missing values are always pain, because they are just, for instance, you have gender, you have 30% of men, 70 or 65% of female, and 5% of I don't know what. And it's just giving you this pain that you have to, always you have to deal with this missing values. It would be much easier, for instance, to just either forget about this 5% or just do something with it. For instance, imputate the mean value of the gender, or let's say something like that. Also, duplicate values are something which is a pain. For instance, if you're dealing with a customer data or CRM data. It's a problem if you're doing, let's say, a campaign and a customer which is by some vague mistake in the database 5 times, and this customer gets 5, I don't know, invitations to a campaign or 5 leaflets. It might make this customer a bit angry or not, but it will definitely cost the company 5 times more because of these duplicate values, etc., etc. And at the end, of course, going to an analytical department and asking people there, can you give me this, can you give me that? Yeah, it might give you a headache, because you have to wait for those guys to give you the final report, and you always have to double check whether the values are correct, whether the values are this and that. If the communication was fine, if people understood each other fine, etc., etc. So all this was effectively the idea behind why R can be and could be and should be somehow implemented for the statistical benefits of the data stored in the SQL Server 2012 in this case, or 2014. Okay, so the environment. In my case, I'm using a normal environment, Windows 7, Windows 8. So setting up the environment just means that you have to have an instance of SQL Server, you have to have R installed, and you have to have some sort of a local access to your folder where the data will be stored, where the file is going to be stored. And of course, you need to have a statistical problem or statistical solution or something that you want to do some sort of a statistical analysis on. So let's say I want to combine cross-evaluate whether gender has some sort of influence on my sales. Of course, I can do it in Excel. I can do it somewhere in OLAP, in third-party tool to browse OLAP cubes. But giving the data and having this without any statistical significance, it might give you a wrong decision. For instance, I'm looking at the gender, whether the gender has any kind of influence on my sales, and I see a lot of potential. I see, okay, 30% of male, 70% of female. Okay, this is my distribution against the income, the sales. But then I might say, okay, this is my decision. Okay, let's give the women more, I don't know, more discount or additional, putting in the additional campaigns, giving them additional offers. But then, let's say a data scientist from the statistical department or somewhere says, what about the statistical significance? Can you check that? And you say, oh no, I don't, I didn't, I couldn't, I haven't. And for instance, it turns out that there is no statistical significance on this data. And then you see that, okay, so what am I going to do now? Yeah, okay, I shouldn't do anything with that. So this is the reason also why you need to have a statistical problem, and that's why I'm going to use R to see whether there are any correlations or not. Prerequisites and configuration. So going back to SQL Server, you definitely have to have, if you run sp-config, you need to have all the automatic procedures turned on, and you will need to have XP CMD shell turned on as well, mainly because through XP CMD shell, SQL Server will be communicating with R. So in this case, yes, I've talked to a lot of people, and they said, yeah, this might be a potential threat to the security. I said, yes, it is, but please talk to your local DBA, figuring out what is the best way to have the access, and that's it. As I said, you have to have installed R. On March, the beginning of March, R 3.0.3 version was released, so you can use that as well. You will definitely need to have some other libraries, and that's it. And as I said, a read-write permission to your local program. So that's about it. So now hands-on on the procedure. In this procedure, I will guide you through the code. I will run some code. We will see the configuration, and then we will talk about the structure of the procedure and how to use the procedure, what kind of data can we analyze, statistically analyze, and what is the outcome. And I will definitely show you how to print the results. And upon that, at the end, I will give you some ideas what can we use this for, especially if you're using a reporting services, if you're using any other tools, how to deal with that as well. Okay, so now I'm going to switch to my SQL Server Management Studio. Okay. So first of all, configuration. I'm using AdventureWorks 2012 database, and I'm just extracting some random data from the sales person demographics, and this is my set. I've deliberately chosen a very small data set just for the sort of the demo. I think it's roughly 20,000 rows with very little data, as you can see. It's gender, total children, and number of cars goes on, and this is the code. And this is the data and the prerequisites. As I said, you need to configure the XDCM shell and all the automatic procedures. This is only those two are for the purpose of SQL Server that can communicate with R. Okay, now to the procedure. First of all, as I said, we're going to go briefly through how the procedure is set and what it's doing what the procedure is doing, and then we will deep dive in the procedure. First of all, there is a table. First of all, there is this table where I'm configuring, this is ID auto increment, our statistics, which is just the name of the statistics, and our code, and the number of values this statistics can hold. Just briefly, if you want to see the summary of your data set, in this case my data set is set to FO, which is a default value. You don't need any variables, but it will just generate some sort of descriptives for your data set for all the full variables. In my case, the variables are these are my full variables, and in the summary FO will just generate the statistics, descriptive statistics. I have to say this, all this is part of the R code. It has nothing to do with SQL Server. It's just a static table where a user can add additional rows with additional statistics as much as you want. In this case, I'm running the crosstabs. For instance, if I see the statistics number 3, I'm running the crosstabs between two variables. I can do 3, 4, depending on my needs. And this is the T-SQL test. And also some cross tabulations with percentage, etc. It's just to show you briefly how to deal with this and what to do with this. Okay. Once we have this, the procedure is set to check, as in here, procedure parameters. Okay. So the procedure parameters are the this is the procedure, are the input parameters that procedure needs to use in order to generate statistics. So first of all, target table is my target table, from where I'm getting all the data. The name of the variables, so in this case I'm just using two variables. The statistics is just the number of statistics. In this case, as we've seen, I'm going to use the frequency table, which is corresponding to this ID in this table. The server name, the database name, the working directory. In this case, is just a folder on my laptop, and the path to R. In this case, I'm having my R installed under C program path, etc., etc. So these are the input parameters which I need to define. In this case, whenever you run this, you will just run those three. You will need to change effectively target table variables and statistics. For instance, I want to see the heat square. I will just change it here to 3, and then which variable and from where I'm getting the data. Okay, going back to the procedure. So in this case, the procedure will be checking a couple of checks. It will go through whether there is the working directory, if there is a working directory existing. If it's not existing, then it will create. Then we'll check all the input variables. This is something which I needed to do because it might be that you are not using your target table, and then it's absurd for running this procedure because there are no data coming in. So in this case, just saying whether there is something defined or not, and running again for the statistics. So this is the second variable. So the variables, and then our path is just saying whether you're inserted something or not, defining the server, the database name, etc. And then the working directory, if there is none, it will create one. And then the R path, whether there is file existing in this R or not. Logical checks, also some logical checks will be presented here. In this case, whether all the variables, in this case those two variables, if these two variables are presented in this table. So if I'm running the select statement from this table, this is my table. So let's say I'm running, this is my table. So with column names and some values, and this part of the procedure is just checking whether the column names are corresponding to the table. And again, if the server, which is also an input variable here, the server name, if this is the correct name, it will also check that. So this was the first part. It was just checking all the variables, whether they are fine. And the second part is effectively generating the R code along with the variables, input variables presented right here. So these are my input variables. Based on that, I'm going to generate R code. So in this case, I'm just running a couple of R statements. Those who are not familiar with R, all the documentation is available online. You can always extend this. You can always use this part the other way around, the way you want it. But at the end, how the R, this is my R Studio, this is what it will generate. So just briefly going through R, it will set my working directory. Then it will check whether this library is available. If it's not available, it will install the library, set some ODBC connectors, and this is the path to my data SQL Server. This is my query. So this is the query which I'm running, and the name of the statistics, and where to store my data. So effectively, I'm storing the data into output text file, and that's it. So this section of the code will effectively generate based on your needs. It will give inside here set working directory. It will give the working directory from this input variable, etc., for all this. So server name, database name, and the query statement. So in this part, it will just generate what's ahead of this R code. In the second part, it will go through, it says here, it will list all the R statistics, and it will go through this two parameters, input variables, and it will generate, again, R statement. So effectively, at the end, if I'm using the output, so if I'm using, this is frequency table, if I say I want to use the frequency table, I will, it will go through and create this section of code. And this section of code is by default available in this table statistics, as I said. So it will take this one, and it will replace the variable, I think it's this section here. Actually, just put it here. It will take this part and just go through all the variables and see which variables are available and replace it. So all this section is available here. Keeping in mind that if you want to add your own statistics, so let's say I want to add under number 8 additional statistic, let's say I want to see the Pearson test. I put the Pearson test here, the name and our code for the Pearson, the number of variables I'm using, and then I will definitely need to either copy-paste section here and put the statistics 8 and just say what kind of variables I'm using, and that's it. It could be done also more dynamically. I totally agree with myself, and for those who are thinking the same as I'm thinking now, but otherwise, yeah, it's just copy paste and that's it. And at the end, it will store all the data. This is the close result. It will close the connection. So going back to our code, it will just concatenate at the end this part saying that please store all the results in my text file and close the ODBC connection to the SQL Server and let R do the rest. So this is one thing. And going back to the presentation briefly, so we said that we're going to generate R script, and then at the end we're going to print the result back to SQL Server. So in this case, what it will do, it will create, now the code is generated, and it will be sent through this one here. It will be sent to R. So in this case, R will be creating a statement. In this case, we will generate the statement in the text file. And this is the part where R is going to be called and generated. So if I look to my file server, so just quickly down to here. So this is my file server, which is as an input parameter is defined here. So this is my working directory. This is what at the end I will get as a return from R. So it will just call the batch file for R, and it will generate all the code. First of all, the code is stored, all the code is stored here. So if I put here, reload, so this is my code. This is the R code, so effectively I'm calling from the batch, and this file is going to be a part of my batch. So if I will be just effectively copy-pasting this code to my R Studio and just running it over, I can just run it. It's running here now, and it will generate, so the connection is closed and the file has been generated. In this case, this is my results, so it will just return the process time, how much time does it would be needed for this, and also the output. So this is my output file saying the frequency tables for my desired, so in this case it was total children, and it says so many observations, 6,653 observations had no children, etc., etc. In this case, as you can see, the numbers are coming very raw. You can add additional R code here just to say that you want to have additional labels on your code, or if you want to have recoded values instead of 0, you might say no children, etc., etc. So everything can be done, and it's very useful to be done. So going back to our code, at this case we are just getting the data into a file. At the end, what I want to do is I want to have the data and the results printed in my management studio. So in my management studio, as I said here, it's printing the results back to the management studio, which is effectively very good if you're doing some sort of analysis, and you just wait and you will get the data back to the management studio. It is just some code here to generate the results back. It's using the SPO get property SPO a method, and that's it. So create method called, getting the property again method, and destroying all the object. And at the end, I'm just cleaning some of the data. So effectively, this is very shortly the procedure how it is working. And in reality, how does it look? So this is, for instance, my procedure, and if I want to have this run, I just say, okay, this is what I want to do. I put then, it's executing. Now the query is preparing the statement. The statement goes to to R. R is preparing all the, in this case, cross tabulations, and it's storing the results to file, and the procedure is calling that file back to the Management Studio and printing it here. So this, in case, effectively is a sample case of cross tabulations. Let's say I want to use delete the table. Let's say I want to use, sorry, the gem here. I want to use some other statistics. Oh, come on. So I want to use, let's say, frequency tables. I just put 2. So in this case, I'm going to be putting 2. And I'm going to be putting, let's say, total number of children. I will be running this. And in return, I will be receiving a frequency table of this variable. I can also say I want to do 4, which I think is the T-SQL test. It will also give you the result back. So in this case, this is what it's very useful, using the procedure, using this framework to generating the data. In this case, I've received the T-SQL test for given probabilities for a defined variable. So this is one part, how you can use in management, SQL Server Management Studio. If you want to use, you can also use it in reporting services. In reporting services, every time you generate, for instance, if you're using the RStudio, every time you generate a plot here, it can be stored the same way as it's stored here, and you're going to have your report in the SSRS, calling this file and presenting it in the report, or you can do the other way around. You can store the JPEG to a database, and you can present this JPEG, for instance, if you're drawing a canonical or discriminative analysis graph, and you just want to store the JPEG to a database, and once you run the report, it will call this procedure, store the JPEG and some additional statistics or data, and it will pop up in your report as a file with some additional statistics. So in this case, you might have your end user now picking up their own statistics based on your procedure, saying you can use, for instance, if they are some heavy statistical users or data scientists, you can set them whatever they want to have, for instance, analysis of variance, ANOVA, MANOVA, regression, stuff like that. You can set them, for instance, as a filter in your report. Your R code can generate the statistics against the data you're having stored in the SQL Server, and as a result, you're going to have this data saved as a JPEG with some additional statistics, and or as a file, or just inserted in the table, and then read from this table, file, whatever, in your report, and that's it. So in this manner, it's much easier, it's much faster, it's much cheaper. But just for the end, I just want to sum up. There was some problems, as I might say. People were having problems when they were installing the additional libraries, and I must say that yes, you have to be very careful when installing the libraries for the R, so that they are correctly called. And yes, it's in memory. It might, if you have low memory, or your computer is not that, as a server, for instance, you might have problems with some sort of latency. It might just need a bit more time, especially if you have a large data set as well. But otherwise, yes, all the availability is effectively what's in your for instance, in a report or in our management studio. So that's it for now. I've just guided you through the framework, how it is working. I definitely encourage you to use the R, because R is definitely the it's just growing, the community is growing, the people who like it is growing, and it would be a pity not to use it in SQL Server the way I've shown it today. People that I've also been talking to, there were also some other ideas, but they found this a great idea, so we'll definitely encourage you to use it, and that's it. So now back to Jen and the questions. Thank you. So we have I'm not getting the Jen. So Jen, are you here? If there are any questions now, please, Jen will be helping, and I will be answering the questions. Jen?
Hello there, sorry. Could you hear me? That's better.
Yes, I can hear you now. Yeah.
Sorry about that. So the question was, is it possible to install RStudio? So here we are. I hope everybody can see the URL. So just go to rstudio.com. The URL's at the top, and you should be able to find it there. And Sal is asking, after the webcast, where can we find the slide deck and files with the source code? So there's a few people asking if we could share the stored procedure.
Yes, we can share it. Sorry, we can share it. Yes, the slide deck and the code, no problem. Yeah.
Oh, that's very kind of you. Thank you.
Yeah.
Another question is, instead of writing to an output file, is it possible to write to a DB table, to a database table?
Yes, you can. You can write back to the table. it's just a bit complicated, but yes, you can write it back to table and then read the data from your R from the management studio and then use the data. It is just the problem. It is the data might not be in a JSON format, or it's just a free text, and it's a bit problem to concatenate to substring the data. You might as well just store it in an XML file, which might be a bit easier or something like that.
Yeah, that's true, because then you could use SSRS to read in the XML file and then import it that way. So yes, there's ways and means to do it, and I'm sure people will have fun trying it out. So another question, we've got quite a few questions, which is good. And Sal is asking, do you have any experience and the use of GPUs instead of CPUs?
With the GPU, honestly, I haven't had any experiences with R. So unfortunately, no. There was a huge debate, talk about that R will be in memory. So yeah, I don't know where the development on that is now. But with the GPU instead of the CPU, I haven't read anything regarding the R except for the bit concept. But they are not yet.
We have another 2 questions, and I think that's us. So in your example, how would you go about using R from a Linux box with more memory so that the SQL Server or the workstation wouldn't be bogged down with the process of the data? When I looked at this question, I thought it's not just a memory issue. If you were doing this in a corporate environment, you may want to split out the functionality anyway across different machines if there's a lot of data and a lot of queries. But I personally don't have any experience of Linux, so I can't comment, but I wondered if you had any thoughts, Thomas?
It's a good question, yes. There were also some debates on parallelism in R. You can run on Linux. You can either run in parallel if you want. So in this case, you will generate much faster the data. But again, as I've said, there is a debate on using in-memory technology, so you can cope with a much greater set. But as for the Linux, I don't have any experiences regarding that. So yes, but as I've said, the guys are doing a lot of work with the parallelism and as well as the in-memory technology. So yes.
Sounds good. And I'm just going to put back to your screen if that's okay, so you can show your contact details. The last question is about how the use of code can be used to profile source data. And do you know of an open project where people are actively working on this?
So open project that the people are working on integration R and SQL Server, or sorry.
Yes, the question isn't very clear. I'm sorry. It seems to be in 2 parts. The question is really, do we know of an open source project where people are working on profiling source data? I mean, I personally don't know of one. I think the problem is that a lot of source data is still private, and any data that's open source tends to be as is. And often people will take the public data and cleanse it up and then try to sell it anyway.
Yeah, that's
so true. I couldn't see any online projects where people cleanse data, but maybe one day.
Yeah, maybe one day. Neither have I found, but there are a lot of libraries. For instance, the Anna Harbor University in Chicago. I know that they have a lot of data available online. There is for those guys who are more into research, for instance, there is a European social survey, which is also, it's not a transactional data, but you might get a lot of different data, publicly available data, and all the data which were funded for those guys who are coming from the European Union should be free available. Yes. For the cleansing part, yes, I I haven't seen whatsoever no projects that would be running like this. But yeah, if the listeners have, and yeah, it would be great to share them. Yeah.
Yeah, that's true. Well, we only get a few comments, people saying thank you very much for the great session. So it's just for me to say on behalf of the audience and all of us at PAST, that was a brilliant session. And thank you very, very much for taking the time to prepare that for us. I really enjoyed it. And I will post it on YouTube as soon as I can. And I look forward to watching it again. So thank you very, very much, Thomas. And wherever everybody is in the world, because we are global, and I love looking at the names on the attendee list. It's people from all over the world. It's just amazing. I love this. So we're broadcasting tonight from Europe, but wherever you are in the world, good morning, good evening, and good night. And thank you very much, team. Thank you.
Thank you, Jane, and thank you for inviting me, and thank you to all the listeners that you have been tonight with us tonight. Yeah, thank you.
Thank
Good
you.
night.
Bye.
Good evening.
Bye.
Good morning. Bye. Bye. Bye.